off.
Great, thank you, Becky. I'm Christine Brinker, and I'm here with Carl Linvill and Rich Sedano. Thank you all again for joining us on our webinar today on standby rates for combined heat and power. As you probably know, combined heat and power, or CHP, is a very exciting and very valuable suite of technologies, and we are glad that you all are engaged with us in helping to encourage and facilitate more cost-effective and well-designed CHP systems where they make sense. I'm going to make an educated guess that all of you are fairly well educated about CHP and are familiar with the basics, but just so that we're all on the same page, let's start by saying that CHP is essentially local or on-site generation that makes use of heat that would otherwise be wasted. Now, businesses invest in CHP for reasons of efficiency, reliability, cost savings, sustainability, and a host of other reasons as well. Those are some of the main ones. Now, on the subject of cost savings, part of the puzzle is ensuring that standby rates are effectively designed. Standby rates can significantly impact the economics of CHP systems by offsetting some of the cost savings that are potentially inherent to a CHP system compared to a grid-supplied electricity supply and a boiler, thus making the case for CHP less compelling and less vibrant. Hence our diving into this issue today. We want to discuss how standby rates can be effectively designed, some of the pitfalls, and also some of the aspects of well-designed standby rates. I mentioned that I'm Christine Brinker. I'm the director of the U.S. DOE Southwest CHP Technical Assistance Partnership. We also call ourselves CHP TAPs. And we are one of 7 CHP TAPs formed by the Department of Energy to transform the market for CHP, as well as waste heat to power and district energy systems that use CHP. We do this through several fronts. One is technical assistance to businesses that might consider CHP. We help them figure out if CHP is a good fit, both technically and economically, for their particular situation. We offer screenings and feasibility analysis. We answer any questions that they have, and we basically help walk them through the process. We also provide education and outreach, including webinars such as this, to help get the word out about CHP and to inform both prospective CHP adopters and policymakers and regulators about the benefits, about the business models, about the resources available for their specific situation, and to promote CHP as an effective clean energy policy solution. The third area where we work is working with stakeholders such as yourselves on figuring out where CHP makes sense and how to reach our national goal of 40 gigawatts of new CHP by 2020. That's a little background on the CHP TAPs, the DOE CHP TAPs, and here's some more context as well. This webinar here on standby rates stems from, or at least very much ties into, the C Action Network, or State Energy Efficiency Action Network, which is an effort facilitated by the EPA and DOE jointly and comprised of more than 200 state and local policymakers, plus other leaders and professionals who were tasked with building out energy efficiency to its full potential. So the C Action Network builds upon the National Action Plan for Energy Efficiency, and it provides best practices and recommended approaches on key energy efficiency policies and program areas based on effective and proven state and local experiences. It's really designed to provide support on energy efficiency policy and program decisions for utility regulators, for utilities themselves, for consumer advocates, legislators, governors, local officials, air regulators, energy office directors, and other stakeholders. They have a whole wealth of resources. It's an effort that's a couple of years old by now, so they have a lot of webinars, a lot of reports that are very valuable. And our industrial efficiency and CHP working group is there in that graphic at about 4 o'clock. We're one of 8 working groups that are focusing on the largest areas of opportunity as well as some of the most challenging areas to increase state and local investment in energy efficiency. And as far as goals, the C Action Network has a goal of achieving all cost-effective energy efficiency by 2020. And more specifically, our industrial energy efficiency and CHP working group has a goal of a 2.5% average annual reduction in industrial energy intensity through 2020, and a goal that I mentioned just a minute ago of installing 40 new gigawatts of cost-effective CHP by 2020, a goal that we're well on our way. We're a couple of years into that, and we're on the right track. Now, one of the many outputs or resources coming out of the C Action Network is this report on the best practices and recommended approaches on CHP policies and program areas based on what's worked in other states, including delving into such topics as standby rates, as well as interconnection standards, excess power sales, clean energy portfolio standards such as renewable portfolio standards or energy efficiency resource standards, critical infrastructure, and utility engagement with CHP. So that is a very valuable report. There, the link is at the bottom for you to take a look at. We also have more key reading for you on standby rates in particular in a very valuable in-depth report from RAP that our speakers are going to discuss today, a report that, although it's still new, has already been put to use in a number of states. Utah right now has a standby rate docket open, and this report's been very helpful there. So with that as the perfect transition, please help me welcome our 2 esteemed speakers who are going to take it over from here, Rich Sedano and Carl Linvill. Rich on the left there and Carl on the right. Let me give you a quick introduction to them. Rich Sedano is a principal and director of U.S. programs with Regulatory Assistance Project. He was commissioner of the Vermont Department of Public Service Board, and he has been with RAP since 2001. And Rich has an engineering background. Carl Linvill is also a principal with RAP, and he has worked previously as an academic economist, as an energy and economic advisor to the Nevada governor, previous governor Kenny Gwinn, and as a commissioner in Nevada. He has been with RAP since way back in 2013, and Carl, like me, was trained as an economist. Carl, are you there? Do you want to take it over from here?
Yeah, thank you, Christine, and good morning, everyone. So what Rich and I are going to go through, we're going to tie together a couple of pieces of work. Christine just laid out kind of the National Foundation and the DOE Foundation. We're also going to tie this together with some other work that we're doing on distributed generation. So the first part of this webinar is going to talk about CHP as a customer resource and what compensation, fair compensation for CHP looks like in this time as we transition towards customer resources becoming more and more important. We're going to go through some of the principles of CHP standby rates that are laid out very nicely in the paper that RAP published, but that was written by Brinker and Associates. And then we're going to spend a little bit of time on a deeper dive looking at Colorado and Ohio, just to give you a couple of examples. And then at the end, of course, we'll have time for questions. Next slide, please. So there we go. So we're, the challenging part now, there are so many opportunities as information, communications, and control technology allow customer resources to play a bigger and bigger part in provision of electric service, we're in this period of evolution, and it's going to take some time, and nobody can really tell us for sure how long that time will be. But in the meantime, what we want to do is we want to use the older tools, the established tools like standby rate, and in the case of other distributed generation, feed-in tariffs or net metering tariffs. We want to use these things well. We want to use them in a way that helps to facilitate the transition toward using all of these technological capabilities that we're gaining well over time and making the best use of our most efficient resources. So next slide, please. For discussion about how this looks in general for all distributed generation resources, I want to refer you to a recent paper called Designing Distributed Generation Tariffs Well. While most of our discussions about that paper have been on the subject of solar DG and solar tariffs, and actually a lot of it has been on residential solar tariffs, really our paper is intended to be broader than that. It's intended to encompass a wide range of distributed generation customer resources like CHP. Next slide, please. And as I said, we're combining the information from that report with this great report that was prepared by Selecki, Iverson, and Al-Jabir with Brubaker and Associates on standby rights for combined heat and power systems. That paper in general, it was sponsored by Oak Ridge National Lab, funded by US DOE, is a series of best practice recommendations and provides 5 specific case studies. And we're going to be going through a couple of those in particular. Next slide, please. So what is standby service? First of all, standby service is a set of electric utility products for customers with on-site, non-emergency generation. It provides for utility backstop service for those times when the customer generation is not filling all of the needs. And the terms of standby service are very important because, you know, the CHP adopter has got to take a look, looking out into the future at what's the most cost-effective way of meeting their energy, their thermal and electric energy needs. And the standby tariff terms can really determine whether building CHP is the most cost-effective way, or if being a utility full requirements customer or purchasing power competitively are better alternatives. So the standby service is really very important in that economic evaluation. Next slide. Self-generators purchase energy from and capacity from the utility for a number of different reasons. As is typical in this case that's illustrated here, the CHP owner does not build their system to provide for all of their electricity needs on a regular basis. They typically design their system to meet all of their thermal needs and a portion of the electrical needs. So if you see the bigger green areas, those are sort of regular course of business uses of electricity that are planned for by the CHP adopter. You also see these other situations that are shown in red or that are down below the line. These are situations when the CHP unit is offline for one reason or another. It could be a forced outage. It could be a planned outage for maintenance. It could be a planned outage coinciding with a plant shutdown. For any of these reasons, a CHP operator may need to acquire power from the utility, and the standby tariff, standby rates define the terms of that service. Next slide, please. So the typical components we see in a standby rate include a capacity reservation charge, some as-used capacity and energy charges, a maintenance capacity charge, and facility charges. Next slide. Some conclusions that were, many of these are mentioned in the C Action report that Christine showed a few minutes ago on best practices. They're also reinforced in this report by Brubaker. With respect to allocation of utility costs, it's best that generation, transmission, and distribution charges be unbundled. Generation reserve demand charges should be based on the utilities cost and the forced outage rate of the customer's generators on the utility system. Higher voltage delivery charges should recognize load diversity. And what we mean by that is that oftentimes in designing a standby rate, an assumption has to be made on when the load is incurred. And oftentimes the assumption is, or sometimes the assumption is, that the load, that the peak load of the CHP unit will coincide with the peak load of the system. In fact, there's a good deal of load diversity on the system, and we should attempt to take that load diversity into account and incorporate the delivery charges, incorporate that information into delivery charges. Next slide, please. It's also other areas of best practice that that are mentioned in the report include establishing appropriate incentives. For example, establishing a daily demand charge as opposed to relying upon a monthly or even longer-term demand charge. Establishing daily maintenance demand charges. Customer options that constitute best practice include things like allowing for an interruptible standby service option. So if the customer can change their operations some in response to a price signal from the utility, that should be allowed, and so that the customer can optimize the use of their system and their operations in a way that maximizes the or optimizes the overall operation of the energy system. And also, there should be options built in that allow customers to procure standby service from the open market, in addition to being able to get it from the utility. Next slide, please. So we're not going to go through a few examples that talk about a couple of specific situations. One is Public Service Company in Colorado. The other one is Ohio Power in Ohio. I just want to make a couple points that these examples were chosen primarily because of a willing participation by the state to help in providing information and interacting to make sure that things were accurate and useful. They weren't chosen necessarily because they're the best practices. They weren't chosen because they're poor performers and they need to be fixed. Really, they're observations. They're just examples about which we can make observations. The observations we make aren't intended to condemn the state or the utility. We're just trying to offer some suggestions for improving performance of these units and making price signals work better in all states. And with that, next slide, I'm going to turn it over to Rich to talk about the example of PSCO in Colorado.
Thanks, Carl. This is Rich Sedano. Hello, everyone. So the focus on the Public Service of Colorado standby tariff means that we're looking at commercial and industrial customers requiring more than 10 kilowatts of standby service. And you can note that there are a series of charges, monthly service and facilities fees, also known as reservation fees, and a series of other charges. And in the next slide, we're going to address the generation and transmission standby capacity fee. So In this, there's a term called grace energy, which is essentially an amount of energy the customer can use that's basically included in their demand fees. And if that amount of energy is exceeded, then additional charges begin to apply. So it's an interesting way for the utility to try to plan the amount of energy that might possibly be used during the course of the month. But it is endemic of a system that is reliant on monthly charges and a system that doesn't give the customer very many other options. So we can go to the next slide, please. So we have a series of prospective areas of improvement that we identify. A daily demand charge to avoid, for the customer to be able to avoid, would motivate customers to reduce on-site generation outages in a way that monthly charges do not. And we would like to see customers be motivated to have their units run as much and as well as possible. A rate design that motivates the customer to ask for power when it is cheaper would save everyone money. So a time-of-use oriented system could send that signal effectively. Load diversity assumptions are a common problem in standby rates around the U.S. as the population of CHP units gets larger and their performance as a population can be shown to be very good. Pressure, I think, will increase to fix this, but it can be fixed now with better attention to the load diversity benefits of CHP units across the system. Some states there's the generation and transmission cost bundled in the reservation fee, which is just a practice we think should be improved to improve transparency. Some states with no retail competition do allow larger customers to buy through the normal tariff to purchase market-based power either from the utility or from a seller chosen by the customer. And I think this is, again, looking to find options for customers to manage their situation. So we can go to the next slide. So we have several suggestions. The way that the monthly standby charge is calculated should be based on the most reliable utility unit. There's a link that we will forward to you with the announcement of the availability of the recording to a series of spreadsheets that will demonstrate this better than a webinar will do very effectively. But the monthly charges based on the way that Public Service of Colorado and many other utilities do it don't focus on the most reliable of the utility units, and we think that's important. The tariff should incorporate a daily charge that can be avoided, and this demand charge can be drawn from the full service tariff for the applicable customer. And if there's a monthly demand charge there, then it should be that number divided by 30 to get to a daily charge. The customer can be given the means to avoid monthly and daily charges through an option to buy power at lower prices. And if the power is available, then they can take advantage of that. And the customer can be given the option to use demand response to reduce the service demand it imposes on the utility. It can demonstrate its capacity in a load reduction plan, and in this way motivate them to improve their facility and make more cost-effective use of the utility backup services. We again mentioned the G&T fee and how that should be unbundled. There's no good reason shared facilities should be charged fully to each standby service customer. The proper share of shared facilities is the fair way to price them, and that's not typical here and in many other situations we looked at. And charging demand charges during on-peak hours will motivate the most reliable customer operations during those hours minimizing the effect of CHP customers on the system peaks and capacity costs. So if a customer has the option of when to take standby rate power between on-peak and off-peak, wouldn't we rather have them choose off-peak times to take that? It'll be to their advantage, to the system advantage, and prices should encourage that. So we'll move to the next slide. This is a chart that shows how our suggestions would play out over the course of a month, and as you can see, with standby charges imposed over the more likely number of days that they'll be needed by the customer will save money, and that money comes from better value of the rate design, and also giving the customer then options to even save further if opportunities to do that through demand response or buying through to lower cost power become available. So we'll go to the next slide and talk about a second situation that we looked at, an AEP tariff from Ohio, and Carl will walk you through that.
Okay. Thanks, Rich. Just one other note on that last slide. We don't need to go back to it, but that last slide is a graphic that was taken from the spreadsheets that are provided along with the paper. If you look at the standby rates paper, you'll find links to a series of spreadsheets and results. And that example of a result that Rich just walked through is the type of thing that you'll find in those spreadsheets if you look into it, and I encourage you to do that. So another utility we looked at was Ohio Power, which is an AEP company in Ohio. They offer 2 standby tariffs for CHP units less than 50 megawatts, standby service, a standard standby service tariff, and also a standby service provided by third party or open access distribution standby service tariff. They offer these tariffs in 2 zones within their service territory. The structure within the 2 different zones is similar or identical. There are different rates in the 2 different zones in some cases. Next slide. So some of the features of the standby service tariff, it offers a demand charge based on a forecasted forced outage rate of 5, 10, 15, 20, 25, or 30%. So how that works is that the CHP owner is required to select the forced outage rate that they want to pay a service charge for. The amount of backup power they have available to them is a function of that forced outage rate. If they exceed the forced outage, the declared forced outage rate number in the in the term of the tariff, then the cost becomes very, very high for supplemental rates, and there's a much higher capacity charge. An example in the paper mentions a capacity charge that's about 4 times higher than the capacity charge that they started with. So there's a big penalty there. Distribution charge, which is based on voltage level, and transmission. I don't know why I use the word incremental, but a transmission tariff that's recovered in a rider. Next slide, please. For the open access distribution tariff, there's a monthly distribution charge, which is just based on the level of voltage. It's basically the same monthly distribution charge as the standard SBS tariff offers. And then there's a transmission charge based on what's published in the open access transmission tariff. Next slide. So some opportunities for improvement that were identified in examining the AEP Ohio Power case was that this tariff turns out to be quite complex and difficult to manage. The forced outage rate declaration process that I described is very risky. And while fair risk sharing among the CHP customer and the utility is a very positive thing, this one may be a little bit more on the side of a lot of risk being adopted by the CHP provider. As in the previous example that Rich went through with Colorado, there aren't time of use rates, and there are a few price signals, such as daily demand charges, that allow the customer to have the right price signals to optimize their system and to minimize the cost of electricity for themselves and for the system at large. As I mentioned, there aren't time of use aspects to these rates. There's not any recognition of load diversity, and there's not much flexibility in these tariffs. Next slide. So the specific recommendations that we offered here, and some of these are the same as the ones that are offered for Colorado Public Service. A monthly demand charge set at the system best forced outage rate, a daily demand charge rather than a monthly, or I'm actually not sure if Ohio Power's is a monthly or set on an annual basis. I believe some of these are set on an annual basis. Add an option to buy backup power from the market through the utility in the SBS tariff. Add an option, as Rich has already discussed, for Public Service Colorado, add an option to provide for demand response for a load reduction plan so that they can optimize their operations to minimize cost and to maximize benefits. And reflect load diversity. Reflect when this unit actually operates relative to the demands being placed upon the system as a whole. Next slide, please. In this case, the spreadsheet results that are shown at the end of the paper that you can find, this is just a little example that shows the impact of the rates, kind of a before and after analysis, schedule SBS analysis of what a rate would look like or what the cost would look like for some typical assumptions, and then a revised estimate based on if these best practices were implemented, what kind of an impact would it have. Of course, this only reflects, the effect of some of those best practices. Some of them are more complicated than what you can replicate in a little spreadsheet model. But anyway, I think it's these spreadsheet models are useful for you to think through how some of these modifications to standby service can really have an impact on the cost of operating CHP units. Next slide, please. So with that, I want to open it up for questions about any of this material, and I'll turn it back over to Christine, who's going to field questions and pass them along. Thanks.
Thanks, Carl. Thanks, Rich. If you have some questions, you can send them to us using the question feature in GoToWebinar. A question to start us off is a really good one. Why is it a best practice to incentivize on a daily demand basis instead of time of use for peak or off-peak?
Well, Christine, this is Rich. It's not really a choice. I think each of those has value, and both of them can be done. I think the questions here are for the service that customers are buying from the utility. the customer wants to minimize charges, but also we would like the customer to be motivated to impose the least cost on the utility system, and therefore the least cost on in the long run on the customers who pay for the utility system. So a daily demand charge can motivate the customer to make outages last as short as possible, so that if they have to, if they're able to avoid demand charges on all the days that they run and only incur them on the days that they aren't running fully, then they'll minimize the number of days. And in terms of time of use, again, motivating them to operate all the time when power is most expensive to produce is an incentive that will make their imposition of costs on the utility as low as possible if they able to focus their downtime on off-peak and lower cost hours. So both of those are good motivators, and both of those are not typically found in standby rates.
Great. One short clarifying question. When you're discussing forced outage, do you mean unplanned outage?
Yes, there's a definition in the paper about what a forced outage rate is on page 10, and so for emergency reasons is a good way to think about it. Things that are unplanned, right?
And then related to forced outages, how does the utility calculate the forced outage rate for its units?
Well, this is something that I think our writers found somewhat challenging, actually, to unpack, but they seem to be based either on high forced outage rates or average forced outage rates, and we felt that the best forced outage rate is actually the proper way to make these calculations for what the rate should be. It really does make quite a difference for the way the rates come out, and I have trouble expressing the math. I think this is one of those things where having the spreadsheet to be able to see what it means as the calculations flow through is most helpful. Maybe Carl can explain it better.
Well, I can. I guess the intention is to motivate operators to be as efficient as possible and to incur forced outage rates as low as possible. So customers are going to incur charges for the capacity and energy they use no matter what. Setting the forced outage rate at the best unit incentivizes the utility or the operator properly for trying to minimize their forced outage rate. So,
right.
But it is. I agree with Rich that it's a sticky one.
Right. There are a number of questions about the range of standby rates that we see out there in practice, and starting with a really practical one, did the Colorado and Ohio PUCs implement these changes, and what motivated them to look into this in the first place?
I know that, Christine, I know that there was a docket that the Colorado Public Utilities Commission, Public Service Commission had open as we were completing this report, and they had a copy of the draft as they were moving through their docket, and I know that the docket is now closed. At least I think it's now closed. I can't say that we've gone back, unless you have, Carl, to map what they did compared to with our report. But I know that there was a very active interest in what the report was going to say from the staff at the Commission, who were impatient with us for how long we took to finish it. I don't know that there has been a similar attention from the regulators in the other states we looked at. Yeah, I think that's the other states were happy we were doing this to illuminate issues, but I'm not aware that they were taking the level of action that Colorado was.
Then more questions on the subject of who has done what and what you see out there in practice. You had noted that the case studies that you discussed were not necessarily examples of the best or the worst in the country, but ones that have proactively chosen to get these results. Do you have any opinions on which states or which utilities have a really good approach to standby rates, or conversely, which don't?
Well, I don't have a good sense of who does. I did have a long conversation with the person at the New York Public Service Commission about this report, and asked him if he felt like this report was helpful, and the response I got was that the person at the Commission who's most cognizant about standby rates thinks that the New York system implements most, if not all, of our recommendations. So I haven't done the work myself, but that's one indicator of a place that thinks they're doing a good job in comparing what they do to this report. Generally, we think that most states have not looked at this in a long time. And one of the reasons we wanted to do this report was to bring attention back to it and hopefully attract the attention that would be needed to ask all these questions. We think that most states have a lot of room for improvement.
I would just add that the C-Action report that you showed early on, Christine, has some best practice examples in it, and I would direct people to that report for examples of where things are, a couple of examples of where things are being done well.
Mm-hmm. A follow-on question that's halfway related to that. How receptive are you seeing utilities in revisiting the rate design for standby rates?
Well, Christine, I'm not sure that I can say for sure. In this process, I think this was an interesting process. In 4 of the 5 states, we actually had workshops that the Commission hosted that included utilities as well as people interested in CHP, anyone who wanted to come. And in those situations, I think the utilities involved who have many priorities, and perhaps this isn't one of their biggest priorities, were there to do the best that they could, but we didn't, I don't think, get the sense that they were really excited to be there. And so again, I think we wanted to elevate this as a priority for commissions, and if commissions make it a priority, we're sure utilities will too.
The second half of that question was, do you see the, quote, outside the fence compliance measures suggested in the new EPA proposed greenhouse gas rules for existing generating units as having any impact on the use of CHP and the redesign of standby rates?
Carl, that one's for you.
I don't know the answer to that question, but I was gonna add to Rich's answer on the last question that I think that there obviously is a lot of interest in distributed generation because of the solar DG situation right now, and I think I would say that we haven't seen I haven't seen a lot of action on commissions actively looking to adopt the recommendations in this report or adopt changes to CHP in general. But to me, it seems like that now is a logical time for this to be pursued in a lot of places because there are crossover questions being addressed. These questions of what value does the solar provide to the grid and what value does the grid provide to solar, really crosses over with these issues that we're addressing here on designing standby rates. And as I mentioned earlier on, the capabilities that electric grid technologies are going to provide in terms of making standby rates elicit more economic efficiency are good. So I think even though I would say a lot of places aren't looking at this yet, the time is pretty ripe, I think, for folding in considerations of should other tariffs associated with distributed generation be looked at the same time that we're looking at distributed generation for solar. And as far as the 111D discussion, I'm not really a good technical expert on that area. We have other people at RAP that know a lot about that. But CHP is obviously one of the options out there for reducing emissions that looked interesting.
Right, and I'll just add, Christine, we are working with air directors now on 111D compliance options. CHP is one of the things that we're talking about with them. So I think what we're hoping is that there's more conversation about all of the compliance options, including CHP, and that may focus more attention on CHP.
Right, I agree. And another point on who's doing what in relation to your report, it's worth noting that the report is fairly recent and that it takes a while for dockets in each state to come up where this can be addressed. Often it's in conjunction with a rate case that might be done every year or two. So in Colorado it was held off until I believe 2015 because of a rate freeze. So that's similar in other states where we have to wait for the issue to come up. But I do expect to see some results from the report as each state takes it up. Here's an interesting comment for you both to respond to that says, it seems that best practice as defined by the report is best practices to have customers of utilities to subsidize CHP development. A daily demand charge is a de facto energy charge and does not adequately recover fixed costs.
Well, that is a challenging question, but I think that it doesn't really hold up. The way that markets are working now in a lot of the United States is on daily oriented bidding and scheduling and operations. And I think we're only going to see more of that as we activate customers with more responsive opportunities using demand response, which I think is inevitable with improved technologies that are penetrating homes and businesses now. So to me, I think holding on to notions of annual and even monthly demand charges is is going to increasingly look archaic in terms of the capabilities of the grid and to manage resources and the demands of customers to manage their own use and through that to control their own bills. I think we're going to be seeing some changes that are going to go in this direction, and I think this paper really just underscores some of the motivations on the customer side for that. But the system is going to accommodate it.
How about from a utility perspective? A comment / question that came in says that it seems that many utilities have a distaste for local generation and have used standby rates in the past to discourage distributed generation. And what can you suggest that would make a utility interested or at least neutral towards growing distributed generation?
I've been working recently with the New York Public Service Commission. I mentioned them earlier on the Reforming the Energy Vision docket, and for those who are interested in at least one possible way that the future might play out, there's a lot of material there to look at, and there will be more soon. That approach puts the customers at the center of not only the focus for service, but also the sources of resources. The customer resources coming from supply at the customer level, from responsiveness at customers with efficiency to reduce the complexity of managing the grid, storage to add further flexibility. All of these are potentially going to could be very important and dominant. So what does that mean for the utility? Well, if the utility is asked to accomplish certain system efficiency and system operations objectives and given financial incentives to do that, then if CHP is a good thing for the grid, and I think many people think, well, CHP might be a good thing for the grid if it can inject energy and ancillary services into the local grid where it's useful. If that's a good thing, then motivating utility with performance objectives is a way to make it not only good for society for that to happen, but also good for the utility, because we can work to align their objectives more effectively with positive societal outcomes. So I think in broad strokes, that's what New York is trying to do, and I think that's generally the answer to the question that we need to address in any state interested in this.
Carl, do you have anything to add there?
No, that was
okay.
That was good.
Sure. We have just a couple minutes left. How about a couple nitty-gritty standby rate questions? Again, we'll turn back to that, back away from some of the broader stuff. Would a daily demand charge result in lower demand charges than a monthly demand charge, even if the customer did not operate his unit during that month?
Well, I think we expect that if the customer didn't operate during the whole month, then they would pay the demand charge they would have paid.
Mm-hmm.
But they probably will operate during the month and
right.
and avoid some of the demand charge they would have paid.
Yeah, that's exactly how Utah is designed. If it's off for a whole month for some reason, they would pay what they otherwise would pay as a normal customer. Can you discuss the options for opening it up to allow for market-based backup power?
Well, as I said, in many states, larger customers have what they tend to call the opportunity to buy through the utility. So that can manifest in two different ways. One is that there might be basically a real-time rate that they're basically buying from the utility, and the utilities basically simply mirroring the market price at the time. But in some states, the customer has the opportunity to buy through the utility to a supplier of their choice, even in situations where there's otherwise no retail competition. Of course, in places where there's retail competition, this is not really a relevant question. But this is the sort of thing where I think in states that have allowed this, they've drawn the threshold at a fairly high level so that it's only really the larger customers that do this, and it would be moving the threshold down to allow more industrial and a lot of commercial customers to participate also, or to enable them to use aggregators and move the threshold further down starts to look a little more like retail competition. But I think this buy-through idea can be examined, and the right balance of regulatory issues can be struck so that the people who are most likely to want to use it, even in retail in vertically integrated states, can do so.
There are a few other really good questions that I want to hear your answers to, but we're also at the top of the hour. So I think I better turn to your conclusions now, reluctantly.
Okay, next slide, please. So I guess, sorry that we don't have time to answer all the questions. Perhaps we can answer questions in writing and post them afterwards, and certainly willing to entertain that if people would like that. So our overall conclusions on CHP, and we covered this, some, is that this is a time where distributed generation is taking a bigger role in general. CHP should be a part of that. There needs to be a look at the valuation of all customer resources, including CHP and other sources of distributed generation, to make sure that valuation is lined up with the public interest. And that, of course, means that everyone is fairly compensated, the utility for the services they provide, as well as the DG owner and operator for what they produce and provide. These traditional mechanisms that we have, like standby rate, as Rich mentioned, we're probably, these standby rates are going to become archaic as we have better information and better capabilities on the system. But these mechanisms, like standby rates and feed-in tariffs and energy metering, things like that, they can be done well if we pay attention to valuation. But these traditional mechanisms have the simplicity of being, or the virtue of being fairly simple and fairly well easy to understand. There are exceptions, of course. Sometimes they are more complex than they need to be, but I think striving for administrative simplicity while we strive for creating something that does the best job possible conveying value and revealing the public interest is a good thing. Next slide. With respect to standby rates in particular, next slide, please. With respect to standby rates in particular, consider generation, reservation, and daily demand charges. Consider seasonal and on and off peak charges. Consider a scheduled maintenance daily demand charge. Consider a dedicated distribution investment charge. Take load diversity into account. Consider offering interruptible options that allow demand response to work, and provide open market standby tariffs if they're available. And what we mean by that, of course, is that allow the CHP operator to have procurement choices, if possible, to try to optimize the benefit both for the customer and least cost use of energy, which is the benefit of society as a whole. So thank you very much for attending today. And as we said, we will look at the other questions and formulate some responses and post those. Hope you have a great day. See you next time.